Greetings, ladies and gentlemen. Root Beer here, looking at the second problem, problem number 2, on our second part of the Alberta math competition from 2018. So we've got z, it's a set of integers, and we've got a function that takes in integers and outputs integers. Okay? And we've got a nice, interesting little property here. So I find function questions tend to scare people, and you just sort of need to know how to approach them. And in a lot of cases, the functions that you'll actually be making, if you're actually finding functions, are very, very basic. And usually you're handed some property, and here we've got a property, and this is the only thing I really know about my function. What does it do? F of x plus y is x plus f of y. So if I apply f to this, it sort of moves the f over. Okay? It's very important to sort of understand what is your f doing. Is it scaling things? Is it what property have they handed you? Is it something that you can repeat over and over again? Is it something that gives you a certain approach with factorization, or must this thing necessarily look like a polynomial? That sort of a thing. Anyway, so this works for any x and y, and what we want to do is show that f of x plus y is f of x plus f of y. So what they're saying is, if my function on integers has this property, I must have the plus signs sort of pop out. So if an f can rearrange this sort of expression, plus signs pop out. Okay. So I don't think it's very likely that we'll construct our function. We might be able to. Sometimes that's the approach you want to take for these functions, and that, eventually you're able to show that your function is linear. And then, that must not have a constant. And then, if this were my answer, then that would certainly work. And there's some merit to approaches like that, but there's nothing that really makes me think right away that this has to be a polynomial. I mean, it's a function on integers, not on real numbers, so it might not have nice, neat properties like those. But what do I know? Well, I know f of x plus y is x plus f of y. So applying f sort of undoes this f and applies an f here. Right? That's sort of what we've learned. Okay. So what can we do? Well, there's, we've got lots of possibilities with x's and y's. So for example, we could let y be 0, and then really we're looking at f of x here. But I have no idea what f of 0 is. If f of 0 happened to be 0, then f would just sort of undo itself completely. So that's an option, and I do find when it comes to the integers, you probably want to work with 0 or 1, or minus 1 especially. Another thing we could do is we could say something like fix a value for x, and then let y be minus f of x, and that actually makes a 0. And so we've got sort of this nice property, and f of 0 is constant, so that's kind of interesting. So you always get this sort of relationship, although we don't have a way to bring minuses outside or anything like that. But it's still an option. It's still something to look at. In fact, I'll leave it up there. I don't want to. F of x plus that is f of 0. Other approaches, well, we know that applying f once sort of moves this f over here. So if I apply it twice, and so this resolves into x plus f of y, but of course addition doesn't care the order in which you put things. And so what does that do? What does f do? Well, it moves the f over here. Right? So f of this sort of expression is equal to this expression. Now, this is kind of important because, well, we can use x and y to make whatever we want. So you do something like pick an arbitrary x and then pick y so that f of x minus or plus y is equal to some pre-chosen value a, right? So I pick an x, put it into my function, I get an integer out. That's how the function works. I have some value a that I would like, that I want to focus on. I pick y so that f of x plus y is a. There's always going to be some integer that makes this work. And then what have I got? F of a is really just a. So applying the function twice gets me back to a. Now that doesn't mean that f of a is a. Okay? For example, if you have the function that sort of makes it negative x, f of 2 would be negative 2, but f of 2 would be back to 2. So we don't know anything about f itself, but we've got a nice, neat little property here. Is this property going to be helpful? I'm not entirely sure, but it's something I immediately saw. Maybe we should go back to using the zeros. Okay? Now, what do we want? We want, was it f of, no, it's just f of x plus y. So on f of x plus y is f of x plus f of y. Okay. Is there a way for us to use this, to work with this? Well, I suppose I could create some b so that f of b is x. Is that possible? No, we don't necessarily know that the range is all integers. I mean, for all we know, it could be well, I can't be sending everything to 0. Oh. Okay, that's interesting. So, for any a, so ignore, I was just trying to remind myself what the goal was. So for any a, f of a equals a. So a is in the range of my function. So for any integer x, we can find some b, so that f of b is x. Now there might be lots of b's that do this. I don't think that's the case, but there might be lots of b's that do this. Okay. F of x would have to be b. Oh, that's kind of cool. Let's say, namely, b is f of x. I'm just mentioning it to them so that they know what I'm talking about. Okay, well then, f of x plus y would be f of b plus y. And so then what does the f sort of do? It changes it to b plus f of y. Now what do we want this to be equal to? X plus y. No, f of x plus y. F of x plus f of y. That's what I'm trying to say. But what did we just point out? F of x must be b. Which is what we wanted. Okay. So I don't quite know if that was the best or slickest approach to the question, but I'd sort of played around with the properties. So when you're working with integers, as I say, 0, 1, and -1 are good things to look at with functions. Sometimes the approach of polynomials will work, but I really noticed right away, and it's a good idea to sometimes take a step back and say, all right, yes, there's a lot of symbols, but what's the function actually doing? And this function applied to an expression like this simply moves the f over. Okay? And so I sort of got it in my head to try and make it undo itself, and that means you need to do 2f's. And that really nicely leads to this, and I didn't even think I was about to approach the answer, but there it was. It just sort of fell out. Okay? Every integer can be f of something, and there's actually a very particular way to make it f of something. And so this works for arbitrary x and y. You might want to clean up the language a little bit, but there we go. That's problem number 2 done. We are 40% finished our contest here. Up next, we've got problem number 3. We'll take a look at that in the following video. Thank you so much for watching. I'll see you next time.